Good evening, dear friends. This is a continuation of the previous lecture, Basics of Aerodynamics, and in this video lecture, let us see more about the aerodynamic center. And this in this video, we are going to discuss how the pitching moment is. That means how the aerodynamic center is fixed at the pitching moment, and also how the lip curve slope is helping us to find the aerodynamic center. So first let us find the aerodynamic center with respect to the lip curve slope. So first in this for that let us consider the aerofoil and so in this aerofoil we have a chord line. So chord line, this is a chord line, and in this we have a point, that means with respect to the leading edge. So let's say this is our C/4 points, and then at this point the lip end. So let us consider there is a moment. The moment is acting like this, and also lip force is acting. So this is, and then we are considering one more point. That point is nothing but aerodynamic center. So this point is nothing but aerodynamic center. So at this point, so we have to find out how the movement is acting, and now with respect to this point, the distance is XAC. So with respect to this point, so XAC is the distance behind the quarter chord point, because this point is nothing but quarter chord point. That is what C/4 we say. So and this moment is created, so we can say this is a M C/4 moment about the pitch quarter chord point. This moment is created suppose due to the force, due to the lip force, which is acting. Suppose if it is acting at the leading edge from here, then what will be the moment? So that is what we just say. So that is the reason we have taken this is as the clockwise, and then this point now we have chosen. So let's say it's like any arbitrary point. This aerodynamics on a point is something like a arbitrary point, just like any other point we choose on the chord of the aerofoil. Okay, so we have chosen, and let's see how this point is fixed with respect to the pitching moment. So and now let us find the moments about the aerodynamic center. So taking moment about the aerodynamic center, so that what we say, we have to take the moment about this point. So for that we have a forces, and also there is a couple, that nothing but moment is acting at the quarter chord point. So moment about the aerodynamic center is nothing but MAC. So that is equal to this moment is now we are taking moment about the aerodynamic center, that is equal to the summation of other all other moments. So nothing but lift into this is lift into vertical force into horizontal distance, lift into XAC, and also there is a moment acting at the quarter chord point, nothing but MC4. Okay, so now we got the moment at the aerodynamic center. So it is something like we are calculating that in our shear force and bending moment diagram, if you want to calculate the moment at any point, let's say like here it is a aerodynamic center. So if it is any other point like B or C or A, just like that, any other point for any other, with respect to any other point, we will be finding the moment. So like that only we have taking moment about the aerodynamic center. And then this moment, now we have to split up, we have to simplify. That means we are going to divide by half rho v square s c. So because moment is subjected to the Newton meter, kg meter, so whatever it is, so now we are just dividing it by MAC by half rho v square sc, that is equal to lift by half rho v square. Yes, so this is also a force, because dynamic pressure into area will give us the force. So lift by this, so this will become lift coefficient into XAC by the chord length is there, so we are just taking it as plus MC by 4 by half rho v square SC. So here and this will become CMAC. This will become CMAC. After when you simplify, because this is the moment coefficient about the aerodynamic center, then this is nothing but CL into this is XAC by C plus this will become moment about the quarter chord point, pitching moment, that means coefficient of moment about the quarter chord point. So this is, so now we got we have further simplified and then we have converted into moments. That means this becomes the moment coefficient about the aerodynamic center, and this becomes about the moment coefficient about the quarter chord point, and then we have that aerodynamic center position. So now we need to simplify further. So when we are simplifying further, then this is CM AC equal to CL plus XAC by C plus CM C by 4. Then if you are differentiating with respect to the angle of attack, so what will happen? Let's see, because differentiating with respect to alpha angle of attack, so we get CM AC by d alpha. So this we are differentiating, that is equal to DCL by d alpha into XAC by C plus CM DCM by d alpha. So now we all know that the pitching moment is here, that means moment at the aerodynamic center is a fixed point. Moment at the aerodynamic center is the fixed point. So that is what the definition says. So the pitching moment at the aerodynamic center is constant. So that constant, so because alpha is the varying quantity, so this because when we are differentiating the constant, then this will become 0. So because since this pitching moment at the aerodynamic center is constant, so this is 0, and these two quantities will be there. So we need to take it as XAC from this. XAC by C, that is equal to, just if you are simplifying further, then this will become minus DC DCM C by 4 by D alpha by, this is DCL by D alpha. Okay, so now we have got the aerodynamic center with respect to the lip coefficient and also angle of attack and moment coefficient about the aerodynamic center, that means quarter chord point. So how this is varies. So these points now, okay, from this relationship now we have got the definition, that means relationship for the aerodynamic center. So how this aerodynamic center, now we can find it. So that is the matter, because as long as when we have a this lip curve slope, if the lip curve slope is CL alpha curve, this is CL lip, this is alpha. So with respect to this curve, that means when we see here, this is a linear, this from this point up to here, this point is linear. So within the linear portion, what happens, these values, these two values will not be changing. That means the angle of attack with respect to the CM, that means quarter chord point, then that will be fixed, and also this also will be fixed, because this is a lip curve slope. So whatever we are finding here, just here, this is, because this is CL, this is a DCL, and this is D alpha. So we are finding the slope. This slope will be constant within the linear region, and also this is with respect to the fixed point, quarter chord point, this also will be constant. So this, if you want, we can just write it as the moment m naught by a, this is what to say, lip curve slope, that means slope, so a naught. So if I say this two are constant, then if these two values are constant, then what happened, our aerodynamic center also will be constant. So that is the idea, because we say within the linear region of the this lip curve. So what happened, this is fixed, these two quantities are fixed, because this also will not be changing, this also will not be changing. So this will, both of them will be a constant. That is the reason we say aerodynamic center also will be a constant quantity for a region where the lip curve slope is that means linear. Lip curve slope that is constant. So that is the idea. So just this quantity may be anywhere. This is quantity may be based on this after making the calculation. This quantity may be it may be closer to the quarter chord point, or maybe behind the quarter chord point, or forward of the quarter chord point. So that is we need to find out. So when if you do the calculation for any particular aerofoil, then we can find out what is the aerodynamic center, how this aerodynamic center is fixed with respect to these quantities. We will see the